Okay, let's talk about a problem that I bet keeps a lot of you up at night, and that's making sure your autonomous systems can navigate reliably, every single time, no matter where you send them. Today, we're going to dive into the X17, a device that's really engineered to make navigational failure a thing of the past.
So let me just ask you this straight up. Why is it that your autonomous robots, the ones you depend on for the really critical stuff, why do they get lost or just stop precisely in the places you need them to work the most? It's a super frustrating and expensive problem, but it's one that actually has a very clear cause.
Here's the fundamental issue, right? The standard GPS systems that so many robots use, they just aren't built for the real world's complexity. The moment you put them in a challenging environment, their reliability just plummets. And that's not just an inconvenience. It becomes a critical point of failure for your entire operation. So let's dig into that a little deeper. What exactly makes these environments so hostile to standard GPS? This is what we call the urban navigation challenge. Well, the biggest culprit is something called the urban canyon effect. Just picture your robot trying to navigate through a dense city center. All those tall buildings create a canyon, right? They block a clear view of the sky, so satellite signals either can't get through at all, or they start bouncing off buildings like a pinball before they ever reach your robot. And that bouncing around kicks off a whole chain reaction of failure. That's signal reflection. It creates what's known as multipath error, which is basically just feeding your robot bad location data. Now you add in all the radio interference from things like cell towers, and you get the results you've probably seen firsthand. Your robot's position starts to drift, or even worse, the connection just drops completely, and the mission fails.
This exact problem is precisely why the X17 was built. It's not just another GPS unit you can buy off the shelf. It's a complete, comprehensive solution to this whole problem of unreliability.
And here it is, the promise of the X17, really in a nutshell. It's designed from the ground up to give you continuous centimeter-level positioning, and not just in a perfect, wide-open field, but in the absolute toughest environments you can throw at it. So how does it do it? What's the secret sauce? What's the technology that allows it to succeed where so many others just fail? Let's get into the specifics of how it pulls off this kind of total reliability. The simplest way to think about it is with an analogy. A standard GPS receiver, it's like it's trying to listen for one specific voice in a super noisy, crowded room. It gets confused really easily. The X17, on the other hand, well, it's designed to listen to dozens of those voices all at the same time, and it can pull a crystal clear signal right out of all that noise. And here's what that looks like in the real world. It's not just listening to the American GPS system, it is simultaneously tracking signals from China's Baidu, Russia's GLONASS, and Europe's Galileo systems. By pulling from all these different satellite constellations at once, it just makes sure there are always enough clean signals to maintain a solid lock. But it's not just about getting more signals, it's about getting the right signals. The X17 has this whole suite of sophisticated algorithms that pretty much act like a defense system for your data. You've got AIM+, which actively sniffs out and filters away radio interference. And then you've got APME+, which intelligently identifies and just rejects all those reflected junk signals from buildings. The whole system works together to make sure the data your robot gets is clean and accurate. Okay, so that's the tech. It all sounds great, but what does that actually mean for real-world performance? Let's look at the numbers and see how this all translates into results you can actually count on. And this brings us to an absolutely crucial point. It's really a fundamental shift in how we need to think about navigation for robotics. The mantra is this: accuracy is nothing without availability. You have to have both, period. No compromise. So first, let's talk accuracy. The X17 delivers a horizontal accuracy of just 0.6 centimeters. That is sub-centimeter precision. I mean, that allows your autonomous systems to do their jobs with an absolutely incredible degree of exactness. And here's the other half of that equation. Because of all that multi-constellation tracking and the smart filtering, you can expect better than 99% operational availability, even in those awful urban canyons and high interference zones. So that incredible sub-centimeter accuracy is actually there for you right when you need it the most. All right, let's bring this all together and talk about the bottom line. What does this all mean for your operation specifically? This is why it's your mission's most reliable choice. For you, it means you can eliminate that costly downtime and potential loss of the whole robot that comes from it getting lost. It means you can guarantee operational success. Doesn't matter if you're in a wide-open field or the heart of a city. You're basically removing navigation as a point of failure. You can just start operating with absolute confidence in your systems.
So when your mission is critical and failure is simply not an option, the choice becomes pretty clear. The JSX-17 isn't just another component. It's mission assurance. It is, simply put, the reliable choice.